Now here's our situation. We've started here at time t equals 0. This is clock time. I think I misused the word clock time at the end of the last segment. I should have just said time. Anyhow, or time interval. But if t equals 0 here, then our solution tells us that delta t is 1.69 seconds when we reach the ground. It also gave us some information, the 0.26 seconds to the peak, and then the extra time to reach the bottom if we need that information. And if we're trying to completely analyze the motion, we might well want that information. What about the other time that we got? The negative 1.17 seconds. You see, now this doesn't make any sense. It's obviously not going to land here before it started, and that allows us to select the 1.69 second solution over the negative 1.17 second solution, but this solution must mean something. Well, we can imagine that we start a projectile from here or even from some point below. And this projectile has a property that when it gets to here, it's going to be going at 5 meters per second at 30 degrees above horizontal, so that it will follow this path. And if we start our clock at the instant that the projectile passes this point, then the motion of that projectile will be identical to the motion of the projectile that we're actually studying, that rolled down a ramp and came up and moved over here. The two projectiles will join at this point and follow exactly the same path, since they have exactly the same velocity and position at this instant. And that other projectile, coming from wherever it came from, will cross the level of the ground at negative 1.17 seconds. That is 1.17 seconds before it reaches this point. And I sometimes jokingly refer to this as a phantom projectile. That is, this projectile can't follow this path unless it rides a phantom projectile. The phantom projectile started at the beginning of time, at the Big Bang. And since that instant, there's been a phantom projectile going through every point in space, in every possible direction, with every possible velocity. So that when this actual projectile here started its motion at time t equals 0, it picked up the appropriate phantom projectile, or was picked up by the appropriate phantom projectile, and followed the path of that phantom projectile. And that phantom projectile at negative 1.17 seconds was here coming up through the cliff face, or whatever this is. Okay, phantom projectiles, of course, pass through matter without any interaction. They're massless. Obviously they have no reality. Remember, I'm just kidding here. But that phantom projectile was at this point 1.17 seconds before the clock started here, and had exactly the right velocity and direction to pick up this projectile and make it go along this parabolic path.